Hi guys, so this is quite a nice question. We have to find the mass from our moles calculations, but there's a bit of a twist in this one in that we've also got concentration. If you've done GCSE questions on this, it's a straightforward finding the moles and then using that stoichiometric ratio and then working out what your mass is. But in this case, we have a little bit of an added extra, and that is the concentration. So we need to think about that once and we do this type of question. Let's have a read of it. It says zinc chloride can be prepared in the lab and with the reaction between zinc oxide and hydrochloric acid. The equation for this reaction is as followed. A 0.83 mole sample of pure zinc oxide was added to 100 centimeters cubed of 1.2 molar decimeters cubed acid. So here we've got some really useful information, and we know that it's a zinc oxide. Now zinc oxide is a solid that's reacting with an acid. So just use some type of visual to kind of allow you to see what's going on in the reaction in your mind's eye. All right, so here's my zinc oxide, and I might have some acid, HCl, and this is my zinc oxide. Well, let's keep it the same color, like so. Okay, so we've got our zinc oxide and our HCl. Now, we know that we've got a sample of pure zinc oxide, which is fine, so thanks for that. And we know that we have a mole, N equals 0.083, which is our number of moles. Okay. Interestingly, we've got the volume and we've got the concentration. Now we know it's a volume because it's centimeters cubed. When you've got a three-dimensional unit there, you should be thinking instantly volume. So 100, so let's look at this then. So the HCl, the volume equals 100 centimeters cubed. And generally when you're doing A-level chemistry, you have to put things in the right units. And in this case, we've got the decimeters cubed for the concentration. Therefore, we should have the decimeters cubed for our volume as well. So 100 centimeters cubed is equal to 0.1 decimeters cubed. And we also have our concentration, in which case is 1.2 moles per decimeters cubed. Now, some of you would have noticed that the units for concentration is already as is. So all we need to do, therefore, is use our concentration moles formula, which is N number of moles equals concentration times volume. We've got C, we've got V, so therefore we can do the following, which is 1.2 multiplied by 0.1, which gives us an answer of 0.12. Of HCl. That's how much HCl we have because that's what we've been given in the question. We know that because it says it was added to hydrochloric acid, which is the formula HCl. Right, calculate the maximum mass of anhydrous zinc chloride that could be obtained from the products of this reaction. Now here's where you have to be very careful, because you've got two pieces of information and we can straight up use that 0.083 moles. But if you've seen my previous videos on moles and limiting reagents, we've got two reactants, one of which is in excess, i.e. there's lots of it available, and the other is limiting, i.e. it is the one that is going to be used up first. We don't know which one that is yet because we've not got a equivalent stoichiometric number of moles for both. What I mean by that is the following. We know that from the balanced equation we have 1 zinc oxide reacting with 2 hydrochloric acid molecules. So there's a 1:2 ratio. So ZnO to HCl is 1:2. So what we're saying here from this question is that 1 mole of ZnO equals 0.083, which is fine. But we're saying over here from our calculation and from our balanced equation that 2 moles of HCl give us a mole of 0.12. Now, because we want to know which one is limiting, we're not quite sure yet. So we need to do a little calculation here and find out what 1 mole is. So let's write this in red. Therefore, 1 mole of HCl is going to be half of that, in which case we get 0.06 moles. Now we have a fair comparison, don't we? Because now we know that when we have 1 mole of ZnO reacting with 1 mole of HCl, which one is smaller, which one is less or limiting, we can clearly see that this one here is our limiting reagent. So this is the one that we have to take for our stoichiometric ratio scaling. So we need to find out the MR and mass of our molecule. So we've got up to this part, we know that this is the limiting reagent. Now if you look at our balanced equation, we've got zinc chloride, which is the mass that we're trying to find. That's the question mark, that's the mass. There's no number in front, so we have to assume that's also 1 mole. So therefore, we have 1 mole of zinc chloride, right? ZnCl2. Now it's important here to recognize that we have a 1:1 ratio between our HCl and our zinc chloride. So if you've seen that in the equation, you have to be ready to understand that we've also got 0.06 mole of zinc chloride. And the last thing you do then is work out the mass. So the mass equals the molecular mass and the number of moles. So number of moles times the MR. The MR of a zinc chloride, well, what is that? So let's work that one out. That is 65.4 plus 35.5, and there's 2 of them, so it's 71. And it gives us 136.4. This means that we have to work out our mass, which is going to be 136.4 times that by our 0.06, and that will give our answer of 8.184 grams. 8.184 grams. Okay, so here we've got to be very careful that we make sure that we understand that this is the limiting reaction or limiting reagent, and this one is therefore in excess. And we won't know that until we work out how much 1 mole of each there is. All right, thank you for listening.